Okay, so let's start off with this warm-up problem. Pause, give it a try. Randy types 120 words in a minute. How many words does he type in 5 minutes? So use a ratio. 1 minute, 120 words. The rate here would be 120 words per 1 minute, and that happens to be a unit rate. So how do we figure out how many words he types in 5 minutes? Well, we're finding an equivalent ratio. Multiply by 5, multiply by 5. He can type 600 words in 5 minutes. Next example. A machine can pack 70 boxes of spaghetti in 5 minutes. At this rate, how many boxes of spaghetti can it pack in 8 minutes? So what's the given rate? Well, it's 70 boxes per 5 minutes. What would be the unit rate for this? When you're doing these, it really is useful to deal in unit rates instead of these rates that are like per 5 minutes and whatnot. So 70 boxes in 5 minutes, that would be 14 boxes in 1 minute. Remember, all I'm doing is we're taking 70 and we're dividing by 5. So how many of these will there be in 8 minutes? So what we're doing here, if we're going to steal our model, we have 8 minutes. And I know that 5 of those is representing 70 boxes. I'm putting 3 more up here to make 8 minutes. What I've just figured out with this unit rate is that one of these boxes, one of these units, is 14 boxes of spaghetti. So what I'm going to do here is I'm going to take 8 times my unit rate. 8 times 14 boxes over 1 minute. And I should say that the 8 is measured in minutes. So 8 times 14 is 112 boxes of spaghetti. Again, find that unit rate first and then multiply by how many of those units we need. Now I have Ben. Ben parks his parking lot in a parking garage, and he parks it there from 9 a.m. until 2 p.m. on the same day, and we want to know how much he pays for parking. Recognize that that's the sign that we see pulling into the parking garage. The first hour is free. Second hour is $1.75, and after that second hour, the price goes up to $2.50 per hour. So how much does it cost for that first hour? Well, for the first hour, it's free. And how much does it cost for the second hour? What's that second hour's fee? It's $1.75. So for our total parking fee, it's $0 plus $1.75. But then there's a whole bunch of these $2.50 hours that I have to tack on. And what I have to figure out is how many hours am I actually parking there? And this number line is here to help us. There's 9 a.m. I don't know why, but time is always difficult to figure out how much has elapsed. So 9, that would be 10, 11, 12, noon. There's 1, and there's 2 o'clock p.m. So there's how many hours here that he's parked. There's 1 hour, 2 hours, 3, 4, 5 hours. This one was free. This one was $1.75. So how many hours are we parking for that rate of $2.50 an hour? We're talking about 3 hours going by. So 3 hours at $2.50, that's $7.50. So our grand total will be $9.25. Don't try and do time in your head. Do a picture, do a number line, do something to help you make sure that you count correctly. Going into 11 and 12 and then back to 1 again, it gets kind of funny. So be very careful when you're doing this. And this diagram, this number line here, really helps with labeling what each one of these hours are going to be. All of those are 250. Next problem, we have Andy getting new batteries for his video game controller. I'll let you read it. I'll let you cube it. There's a lot of information here. But fill the information into this table to help organize all the stuff that's going on. So brand A is 20 hours. Brand B is 14 hours. And please make sure you're putting units in here. Cost, $3.20 and $2.80. And he wants to decide which one he should buy. Well, the brand B is cheaper, so let's buy that one. Well, it's not necessarily that simple, because you've got to think about what the cost per hour of battery is going to be. We need to figure out the unit cost for buying these batteries. And this is something that happens in grocery stores all the time. If you look at the price tags on those shelves, usually in the bottom corner, there is a unit cost, a unit rate, so that you can compare what the best deal actually is. So hours per dollar, we're going to do 20 divided by 320, because per tells us to divide. And if we do the 20 divided by $3.20, we get $6.25. Or, sorry, units are all wrong here. Holy buckets. It would be 6.25 hours per dollar. So for every dollar that we spend, we're getting $6.25, or sorry, 6.25 hours of playtime. For the brand B, when we do 14 divided by 280, we get 5 hours per dollar. So for this brand, we're getting 5 hours of play for every dollar that we spend. So which one is the better deal? Brand A is the better deal, because you're getting more playtime for every hour that, or for every dollar that we spend. And with these units, as you can see, you have to be thoughtful about what the top and the bottom, what the different numbers in each ratio actually means. Distance, rate, and time. Mr. Anthony drives his truck at a speed of 45 kilometers per hour. We're just going to answer one of these. We'll just deal with 2 hours. We're going to do Mr. Anthony's going at one method. And we're going to look at the racing car using method 2. So for Mr. Anthony, it's 45 kilometers per hour. So 1 hour, he travels 45 kilometers. We're wondering about 2 hours. So if we use one of these bar models, 2 hours, and each one of these units is representing 45 kilometers, we're taking our rate of 45 kilometers times our time of 2, giving us 90 kilometers. And there's actually a formula that's usable here. Distance equals rate times time, and that's what we did. We took the time, 2 hours, times the rate of 45 kilometers per hour, giving us a distance of 90 kilometers. And that's what this picture is showing us over here for Unit 2. This triangle is helping us to remember this. We've got D on top, and broken up on the bottom is S and T, or a lot of times R for rate. Speed is a rate. Distance equals speed times time. So this total distance, the top part, is equal to the product of rate and time, just like we saw in method 1. So we have this racing car. Its speed is 175 kilometers per hour. And it's traveling 3 hours. So we simply multiply 175 times 3 is 525 kilometers. And we can do the same sort of thing if we know other bits of information. Here we have Lucas running around the field at a speed of 8 meters per second. How long does it take to run a distance of 96 meters? Well, it's 8 meters in 1 second. 96 meters in how long? What we're looking for is 8 times what gets me 96, and then we can do the same thing for the equivalent ratio over here. And the way we find that mystery number is we take the 96, the end part, and divide by the 8, the beginning, and we find that we need to multiply by 12 to get the 96 times 12 equivalent ratios, so it will take 12 seconds to run 96 meters. Or we could use distance equals rate times time. This model is showing us that distance is equal to speed times time, or one of these bottom, the speed or the time is equal to distance divided by the other one. Distance is on top, speed and time are on the bottom. So time is equal to distance divided by speed. So 96 divided by 8, and 96 divided by 8 is 12. Finally, the last problem, last example we're going to look at, post A and post B are 9 meters apart. Post B and C are 21 meters. And it takes a bike going from post A to post B in 2 seconds. And it takes the bike traveling from post B to C in 3 seconds. Find the average speed of the bicycle from going from A to C. So we're looking for that quantity. Well, we have to look at our total distances. How far did it travel? Well, it traveled 9 meters plus 21 meters, or a total of 30 meters. And how long did it take to travel that far? Well, it took 2 seconds to go the first stretch, 3 seconds to go the next stretch, so a total of 5 seconds. Average speed is going to be distance divided by time. 30 divided by 5, or 6 meters per second. And you'll see if we look at our rates up here, this rate for the first bit, 9 meters, 2 seconds. So this first part, they're traveling 4.5 meters per second. And then the second bit, this speed, 21 meters, 3 seconds, better known as 7 meters per second. So they changed their speed, but on average they're going 6 meters per second, which is somewhere right in the middle. And that is where we shall leave it.